Hello, everyone, and welcome to today's pre-launch status briefing for Orbital ATK's CRS-5 mission to the International Space Station. I'm Catherine Hambleton from NASA's Office of Communication. Orbital ATK's Cygnus cargo spacecraft is loaded with about 5,100 pounds of cargo for the space station and its crew. The Antares rocket is poised to lift off tomorrow at 8:03 p.m. Eastern Time from the Mid-Atlantic Regional Spaceport, Launch Pad 0A here at Wallops Flight Facility. Here to talk about how preparations for tomorrow are progressing are Joe Montalbano, Deputy Manager, International Space Station Program for NASA's Johnson Space Center in Houston, Frank Culbertson, the Space Systems Group President at Orbital ATK, Mike Pinkston, Antares Program Vice President and General Manager, Orbital ATK, Sarah Doherty, Test Director at Wallops Flight Facility, and Dale Nash, Executive Director for Virginia Commonwealth Spaceflight Authority. After opening comments, we will take your questions. For those of us watching on TV or online, we'll take questions from social media during the update using the hashtag AskNASA. For those on the phone, please press *1 at any time to be entered into the queue. Joel, would you like to start us off?
Yes. Well, first of all, thank you very much, and welcome again to the pre-launch status briefing. The International Space Station program is glad to be back in Wallops. We've missed these guys, and we've missed seeing launches from here. The Orbital ATK team has done just a fantastic job getting us where we are today, and we look forward on the eve of a launch to seeing another Cygnus spacecraft berth to the International Space Station. We have a busy week. This launch tomorrow night starts a 2-week busy traffic period for the International Space Station. So with, as you heard earlier, about 5,000 pounds coming on board to us. We have a launch slightly after 8 p.m. local here. We'll have the berthing on the 19th, shortly after 7 a.m. Eastern Time. And that'll just be 3 hours after a launch from Baikonur, Kazakhstan, with 3 crew members, a NASA astronaut and 2 Russian cosmonauts. So they will launch out of Baikonur, Kazakhstan. They'll be doing a 2-day rendezvous. So they'll be arriving at Space Station Friday morning Eastern Time, shortly just after 6 a.m. local. That'll bring us back up to 6 people on board the International Space Station. That'll be short-lived. Just 10 days later, we'll have the undocking of the crew that launched earlier this summer. They'll be undocking and returning home and ending their mission. And then in early mid-November, actually November 16th, we'll have another Soyuz launch, and we'll go back up to 6 crew members on board the International Space Station. So with that, I want to thank you. I want to thank Orbital ATK and all the folks that supported them getting us where we are today. So I'll hand it over to Frank.
Thank you very much, Joel, and good afternoon, everyone, and welcome back to Wallops. This is a very exciting time for us at Orbital ATK, and on behalf of David Thompson and the entire leadership team of our company, I want to thank everyone who has had a part in getting us back to this point, getting ready for our launch after 2 years. A lot of hard work has gone into this. I especially want to thank NASA Wallops, including the team that weathered the Hurricane Nicole in Bermuda and got it back online for us so quickly, as well as protecting the hardware so well. But everyone here at Wallops, Virginia Spaceflight Authority, the range, the safety folks, everyone who has worked to make this happen. I especially want to thank the members of the Flight Systems Group, the Antares team, everyone who has worked on preparing the rocket and making sure that we are ready to go. The Cygnus spacecraft is also ready. It's loaded with about 2,400 kilograms of cargo that the crew eagerly awaits, as always. Every cargo mission is like Christmas, right? And they never know what they're going to find when they open the hatch. But we'll look forward to that on around the 19th of October. As Joel said, launch time is 8:03, and we'll rendezvous and berth at about the same time in the morning on Wednesday as the crew will come aboard on Friday, so about 6 a.m. Eastern Time. This particular Cygnus spacecraft, as all of them have been so far, is named after a former astronaut. This one is named after Alan Poindexter, Captain United States Navy, retired. Alan is the second fallen astronaut who has actually participated in the assembly and operation of the International Space Station. Alan was a former Navy fighter pilot, a test pilot, and flew on 2 shuttle missions prior to retiring from NASA. He was on STS-122 that carried the Columbus Laboratory for ESA to be installed on the space station, a great achievement in terms of expanding the capacity and scientific capability of the station. And then he commanded STS-131 aboard Discovery, which was, interestingly, a cargo mission, and they carried about 6,000 kilograms of cargo to and from the station. And so we think it's very fitting that Alan is the namesake for this particular Cygnus, and we're very honored to have his name and his picture as a part of this spacecraft. We do have a video that I'd like to run through that will give you a little bit of an idea of the Cygnus spacecraft, what it's consists of, and then the operations that we'll be seeing over the next few days. The service module, which is integrated and tested at our Dulles, Virginia facility, not too far from here. You see in this picture the solar arrays that are also built by Orbital ATK in their deployment testing. And then the Cygnus, the pressurized cargo module itself, comes from Thales, Alenia, Italy, and is brought here to Wallops and then mated with the Cygnus service module, as you see in this picture here. A very delicate operation. Takes quite a while to accomplish, but of course very important in making sure the 2 spacecraft are securely attached together. It's then rotated into vertical, carried to the fueling facility over on the island, and then after fueling it is taken into the horizontal integration facility that you see here to be ready for mating to the launch vehicle itself. One of the last things we do is load some cargo prior to the last closing of the hatch that we call late load. That is things that NASA brings in late that they have been preparing that they need to go on in the last week or 2. Sometimes it's time critical, sometimes it's not. This time it's not that time critical, but it was late. Once it's assembled to Antares, and Mike will tell you all about the launch in just a moment, they deliver us into orbit. We separate from the launch vehicle, deploy the solar arrays. This particular operation actually takes over 15 minutes. This is speeded up because Joel doesn't really want me to talk that long. And then over the course of the next 2 days, we'll raise the orbit as we catch up with the space station and prepare for our final rendezvous and berthing. As we approach the station, of course, the crew will be watching us very closely, preparing to snag us with the Canadian remote manipulator system, or the ARM. And then as we get within 10 meters of the station, they'll actually grab us with the end effector, and then a very delicate operation that consists of mating us with the, in this case, Node 1, and then opening the hatch to see what's inside. And then they begin the activity of unloading the 2,400 kilograms. They'll load us with disposable cargo, or in some people's terms, trash, and then deploy us from the space station where we'll fly away and begin our re-entry operations. During the 8 days following our time aboard the station, we'll conduct. The first one will be a fire experiment on behalf of Glenn Research Center to see how fire reacts in zero-G, and then we'll deploy some CubeSats for nanoracks on the outside of the space station, and that is about real time there. So it's quite an operation. And then once we've completed all of our post orbital activities, we'll re-enter over the Pacific, and this is actual video taken from an aircraft during the OA-6 re-entry. So we do monitor that, and we hope it all comes down in an uninhabited area. Some of it we really don't want to land on anybody's head, nor do you, but it all burns up, and so we feel very confident in what's going on. Again, we're very proud to be at this point, very grateful to all the hard work that's gone into getting us here. And we are ready to go tomorrow, and go Antares, go Cygnus, and now go Mike Pinkston.
Well, thanks, Frank. I'd just like to start by saying how great it is and how excited we are to be back here at Wallops in an operations mode with an Antares rocket on pad 0A, getting ready for a launch tomorrow. I think I've got a short video to talk a little bit about the upgraded Antares rocket. This shows it in a cutaway fashion. The most significant upgrade we've made to the vehicle is the new RD-181. That's going really fast. RD-181 engine. 2 engines power the vehicle. The core has 2 propellant tanks, an RP tank with about 21,000 gallons, a LOX tank that was in blue, but it went really fast, with about 40,000 gallons. You've already seen the Cygnus. The second stage that I missed is a Castor 30 XL built by our Orbital ATK team up in Utah. All of that upper stack is encased by a fairing that's about, we're going to do it again, a fairing that's about 10 meters long and deploys once we're up out of the atmosphere. I think that's enough of that one. You know, it's taken a tremendous amount of work to get to this point between the reconfiguration of Antares, getting the pad ready to go. We had a very successful stage test, which is almost like a launch in and of itself back in May. And then, preparing obviously this vehicle for launch. I want to say thanks and commend the entire team, Orbital ATK, the Dale's Mid-Atlantic Regional Spaceport team, Sarah and the Wallops team for just a tremendous effort, unbelievable hours that went into this and getting us ready for a spectacular mission coming up tomorrow. I think I've got one more video to talk a little bit about the launch operation. This is the vehicle in the HIF. We mated Cygnus to the launch vehicle Sunday night. This is the team getting it prepped and ready for fairing mate. The fairing gets mated, a couple more tests are run, and then we're ready to roll out. This happened Thursday evening. Rolled the vehicle to the pad, got it ready to erect. The countdown tomorrow will start out at about T-minus 6 hours. We begin fueling the vehicle about an hour and a half out from launch. Here we are at about T-minus 10 minutes. This is where we do our final readiness polls and go for launch calls. At about 3 minutes and 30 seconds, we'll actually transition to an auto sequencer that controls the countdown all the way down to T0, and then at T0 we have ignition, and shortly thereafter liftoff. The vehicle does a little wiggle movement there to avoid putting the plume on the transporter erector, so don't let that stop your heart. It does mine, but it's all perfectly normal. And then we're off with stage 1 burning. Stage 1 burns for about 3.5 minutes, at which point we'll separate it. We'll coast for a little bit, and then shortly after stage 1 separation, we'll come up on fairing separation, exposes the second stage and the Cygnus payload, and then we ignite the second stage. The second stage burns a little more than 2.5 minutes to take Cygnus to orbit, and then at burnout, we'll do a little bit of reorientation, and then you didn't get to see it because you saw it on Frank's video, but we'll separate the payload about 9 minutes into the mission. So that's what we got in store for tomorrow. Just thanks again. Really excited to be here again, and my compliments to the entire team. It's taken a heck of a lot of work to get to this point. Sarah?
Thanks, Mike. I'll just echo everybody else's comments that we're very excited, the Wallops Launch Range, to have the biggest show back in town. We've been busy over the last couple of years with other missions, but we're always excited to have Antares back here launching with us. So as far as launch range instrumentation and status goes, we're clear on all of our assets, all of our tracking radars and telemetry sites. Frank alluded to earlier our Bermuda tracking station, after a couple down days due to Hurricane Nicole, fared remarkably well in that weather, and major kudos to that team there that weathered the storm and was able to get those systems back up and running, and they are green and functioning functioning normally at this time. So we're ready to go. Our launch weather officer just a little while ago gave us about as clean of a bill of health as you can for weather. So they didn't give us 100% chance of no violations. We got 95. But I think that's a typical weatherman there. I think their insurance probably requires them never to give 100% chance of anything. So again, we're excited and we're ready from the launch range aspect, and pass it over to Dale.
All right. Thank you, Sarah. Thank you, everyone. The Commonwealth is again very pleased to put on a showcase of where the Commonwealth has come in and created a very strong partnership with NASA and Orbital ATK, a very Virginia-centric partnership. Really, the birth of space, our space program in the U.S. Started here at Wallops. But without the investment, significant investment by the Commonwealth, it would all still be suborbital rockets. It's the investment that the Commonwealth put in that enables us the ability to launch the Antares rockets from here, also the Minotaur-class rockets. If you go out there, you see signs that say on-ramp to the International Space Station, that Frank designed that. We were launching another Orbital ATK mission within 12 days, headed to the moon, and we just wanted to make sure that they didn't get confused and go to the wrong pad with the wrong rocket. So that's why one sign says moon ahead and on-ramp to the International Space Station. So with that investment, we have enabled this national asset that does a lot of capability to really get into the big space program, at least medium-class space program, but the Antares is a fairly big rocket. The partnership has only become stronger through this entire effort. Again, Orbital ATK is a large Virginia-based corporation. We have strengthened and recommitted our partnership up to and including the governor level and CEO with Orbital ATK, and that will carry through at least 2024. We have rebuilt the pad. We have probably never had a cleaner, better-looking pad. Looks really good. The whole rebuild efforts with NASA and Orbital ATK started within minutes after the explosion and has continued on through. We did complete the pad and the rebuild in about 11 months and right at about $15 million, which we shared three ways between NASA, ourselves, and Orbital ATK. As Mike said, the tests came off extremely well. The wet dress rehearsal where you fuel it up but don't fire it, the hot fire where you fire it and don't let it go. Those were two of the cleanest tests we've ever seen and proved out the system, not only the rebuild of the pad but the modifications we made for the RD-181. And this flow has gone, despite Bermuda, has gone remarkably well here. And we are looking forward to putting your rockets out of the NASA Wallops flight facility and playing our part in that. Thank you.
Thank you. We will now take questions from those here in the room as well as those on the phone. Again, for those on the phone, please press *1 to be entered into the queue at any time. And those who are following us on the internet, please use the hashtag AskNASA. All right, let's Dwayne over there.
I think this one's for Mike, Jason Ryan from SpaceflightInsider.com. Mike, you had to make a lot of changes to Antares to use the RD-181 that includes propellant lines, avionics, pneumatics. Can you tell us a little bit about the processes involved to change from the AJ-26 over to the RD-181? Thank you.
Yeah, sure. It took a long time, but I'll try to make it brief in terms of an explanation. We did have to make some changes to the structures that are used to transfer the thrust loads from the engines to the core propellant tanks. The core structure itself was largely unchanged, aided greatly by how close a match the two engines were and some of their key characteristics. We have different control schemes on the engines on the RD-181 than we had on the AJ-26, as well as significant enhancement in the amount of instrumentation we have on board, both of which drove some fairly significant changes to our avionics in order to work together with it. And then obviously some differences in unique interfaces from a propellants and gases and commodity perspective that all had to be implemented. So it was a very detailed, meticulous process, but as evidenced by the stage test, we got it right, and we're ready to go tomorrow.
Jeff Faust of Space News. For Joel, does that Soyuz mission this week create any constraints for either the launch or berthing of the Cygnus if you don't get off on Sunday night?
Good question. So what we would do is, so tomorrow's launch is good, and then we'd have the berthing on the 19th. If we have to push to Monday, then Cygnus would go ahead and loiter while the Soyuz crew would come in and do their docking. The Cygnus capability we reviewed at our flight readiness review. They had worst case 20 plus days, and with a nominal ascent, they would have almost 40 days. So not an issue at all, but the Cygnus would stand down and wait for the human space flight to go ahead and dock.
Other questions? We're here.
Hi, Stephen Clark from Spaceflight Now. A couple of questions. First of all, Frank and Mike, are you working any issues at all with Cygnus or Antares right now? And also, wanted to get your feelings about the launch with the new engines. Are you nervous since you haven't done this in 2 years, or anxious, or what are your feelings now returning to flight? Thanks.
I'll go first. We're working no issues on Cygnus. We're ready to go and anxious to get going. Weatherman makes me a little nervous, but no, I think I'm very optimistic. However, it is a launch, and so any of us who have been in this business a while, you take this very seriously, and you watch everything very closely, and you've got to count on a lot of people. So yeah, we're always nervous, but I'm extremely confident in this team and in this hardware. So I think the crew is going to get their presence on Wednesday. I think we'll get it off tomorrow.
Yeah, I'll just add from the Antares side, we ran our last combined systems test with the range this morning. No significant issues coming out of that. We do have data review that we're wrapping up this evening, and but as of this point, we're not working any major issues. And I'm not sure I could have said it any better than Frank did. We're always nervous, but we wouldn't have a rocket out there if we weren't confident we were ready to go.
We'll take our next question from social media.
Yep, we have two quick questions from social media. This first one is from @ScienceTrek, and they're asking, how do sensitive equipment and experiments get put into the spacecraft so that they aren't damaged during launch?
When we receive the cargo from NASA, it's already pre-packed in bags of various sizes. If it's sensitive equipment, it's also encased in foam, which is good and bad, because once it gets up there, the crew has to deal with the foam that it's all packed in. It's like all those boxes that come to your front door. You got to do something with the boxes after you open up your presents. But they do a very good job of that, and it's packed very tightly in the Cygnus spacecraft with straps that hold it in place. And so far, we've had very, very good success with the hardware arriving, as far as I know, 100% successfully to the space station. And then when they actually take cargo off the space station, and we can carry up to about 3,000 kilograms if they so desire when we leave in about 30 days. They also pack it in foam and pack it very tightly so that it doesn't rattle around inside the spacecraft, and we can control the center of gravity and make sure that everything is where it should be as we re-enter the atmosphere.
Great. This next question is from Project Discovery, and they're asking, are any of the Antares rocket stages reusable? And if not, do they fall into the ocean or burn up?
None of the stages are reusable. The first stage, does fall into the ocean. The second stage may stay up a little while, but it'll not very long. It'll come down and burn up in the atmosphere once it's finished.
Do we have additional questions here in the room? How about over here down front?
Gene McCullough for Talking Space, I guess for Frank and for Joel. Frank, when we were here for Orb 2, there was some discussion about a possible 6-hour mission to the ISS. And I was just wondering, too, if the team was still being challenged to look at that. And for Joel, do you think that's actually a service NASA is going to need in the future? Thanks a lot.
Well, we'd still like to look at that as a possibility, but we really haven't had that requirement laid on us. I think that it would take some additional work on the part of our spacecraft as well as NASA's ability to coordinate with us to make that happen. There may be a time in the future where we'd like to get something to the station so quickly that we figure out a way to do that. Physically, it's possible. Practically, it's difficult.
And I'll just add, right now what's driving the time to get to space station is our science requirements. And we've been able to manage within the requirements we've had with the 2-day rendezvous. As that changes, we'll work with Orbital or any other provider to see if we can speed that up. From a physics standpoint, you can do that. You just have to pick the right days. The Russians generally do that for their Soyuz spacecraft and their Progress spacecraft. Right now, they have a new vehicle that they're just in their early stages of flying, but they'll go back to a 4-orbit rendezvous. So, yes.
And just one thing to add, the challenge of doing that is the timing as the station goes overhead. We have a 5-minute window tomorrow, and we can actually essentially go any day because we can take up to 2 days to get to the station. If you want to get there in 4 orbits, it has to be basically going straight overhead, so you might only be able to launch every 3 days, and it's got to be right on the second.
Got another question down. Oh.
Hi, Ken Kramer for University and Northeast Astronomy Forum for Frank and Mike. Can you talk a little bit about your future hopes for this rocket? Okay, you got a more powerful rocket, higher thrust. You got a steady production line with these new RD-181 engines. So I'd like to know what kind of new missions, too, could be enabled by this. What other satellites can you launch? The other day you announced a satellite you're going to launch on a Proton. Why not on Antares? So talk a little bit about that, your hopes and what you can do with Antares in the future. Thanks.
Cover the payload part. Yeah. On the satellite side, Cygnus is very compatible with Antares, and we are actually proposing the use of Cygnus for other applications in low Earth orbit, to include satellite servicing and other things that are coming in the future. Antares would continue to be the ideal launch vehicle for most of those missions. For other spacecraft, for example, the communication satellites that we build are also in my group. But in order to get to a geostationary orbit, it takes a different upper stage than what the current Antares has on it. So we'd have to modify the rocket, and Mike can talk about the future of that. But we've looked at a number of different variations, and as I said, the Cygnus can be used for a lot of different purposes. The technology that we use on the Cygnus can also be used for a lot of different missions and a lot of different objectives, and we are evolving that into other spacecraft.
Yeah, and I'd add, there's nothing about the Antares rocket that makes it, unique to the CRS mission, certainly, and we've got aspirations to market and sell it for other satellite applications, anything in the medium class. As Frank said, a lot of those applications would require, development of an alternate upper stage capability. We've got thoughts on that we could put into work in the future, and certainly in our current configuration, we're looking at NASA science missions. Certain commercial opportunities that may emerge. I think in all cases, a successful flight is going to be an entry requirement to any of that, and so that's why we've been just squarely focused on the OA-5 mission coming up. But certainly in the future, we're looking to do more with Antares than just CRS.
All right, we're actually going to go take a question from the phone first, and then we'll go up here in the front.
Irene Klotz with Reuters, your line is open.
Hi, thank you very much. I actually have 2 questions. The first is for Mr. Nash. After the accident, there was quite a controversy over payment for repairs for equipment and facilities that were owned by the state, not U.S. government and not Orbital, which you didn't have insurance for. For this mission, has Mars now purchased insurance? So how much? Thanks.
We worked through that. We are covered by insurance, what we believe the maximum possible damage is, and have that in our agreements with Orbital ATK and with concurrence from NASA.
Okay, we'll go to the question down front here.
Hi, Jeremy Cox with DelmarvaNow.com. You all had talked about the hot fire tests occurring, and that these are new motors being used for the first time with this particular spacecraft. Is it unusual to not have a test flight under these circumstances?
I don't think it's unusual. We certainly feel like that first of all, the engines themselves are all tested to the full flight duty cycle before they're delivered to us. And then, the stage test that we conducted back in May is a fully integrated test of a, fully flight-like first stage. Provides us significant data. There was a ton of data, including extra instrumentation that we added just for the test that's beyond what we typically put on a flight vehicle. And then we spent a lot of time digging through it. So, we're completely confident that that gave us the information and the data we needed to, really assure ourselves that the vehicle is ready to fly.
And the payload side of the equation feels good about it, too. The first stage has been changed, but we understand those changes, and we feel like all the tests covered the risks that people have been able to think of that we'd have to address. And we have a lot of experienced people in this program who have flown rockets for the first time, and these engines have flown in slightly different variations on other rockets. As far as everything from the first stage up, the changes to that are very minor. The spacecraft itself is different than what we were flying in the first part of this program, but we've flown it twice on another launch vehicle. So we feel very comfortable that the entire system has been wrung out. We do understand the risks, and we have a lot of confidence that it's going to work as designed.
And I'll jump in as well. NASA's been integrated with the Orbital ATK team. We've had people from our Marshall Space Flight Center, engine experts, people from the Launch Services Program out of Kennedy Space Center. We've traveled to Russia with this team. We feel confident as well with the Orbital ATK plan.
All right, we're going to take a question here, and then we've got one down in the middle here.
Thank you, Mark Harmon with SaveManSpace.com. Two questions. I want to follow up from Ken's question. Could you launch CubeSats with any unused cargo weight? And number two, you had the Sapphire experiment on the previous launch. It'd be interesting to know the results of that, and is there a follow-on this current flight?
I'll take that. As we showed in the video, we did have the Sapphire on the previous mission. We have a very similar experiment on this mission also that, as I mentioned, we were going to conduct shortly after unberthing from the space station. And then it'll take us a few days to download the data from that, the video, etc. It's a different configuration of the samples and the burn rates that they expect to see, but it will be a similar experiment. And I think it'll also be very informative to the designers for future spacecraft. The CubeSats, as I said, we're going to deploy an additional set of NanoRacks CubeSats on this mission, just as we did last time. That's what the video was that you saw from the previous mission. We will do it from above the station this time rather than below. That'll give them a little longer time in life, or orbit life. But we'll be well away from the station by the time that occurs. And it should be a very exciting time for the folks who have built the experiments that are going to go on those CubeSats. And we can do that on every mission if we are asked to do so.
Yeah, so we're deploying 45 kilometers above the space station, and that was in a direct request from the science and research community, from the owners of these satellites. They said, hey, we need more orbit lifetime. Can you go above ISS? We worked with the different teams. We worked with Orbital ATK to make sure we can get what we needed, and it's a huge success story.
We also had a science briefing just before this briefing in which we had investigators talk about those two investigations specifically. You can catch that on YouTube, and we'll also have those investigators back tomorrow for reporters that want to do one-on-one interviews. You can sign up for those at the media check-in station if you're interested in learning more about those as well. And now we'll go down here to the middle.
Hi, Jared Hayworth with We Report Space. It's a question for Mike. Frank had mentioned the 5-minute launch window that you have. For the upgraded Antares, what does the recycle time look like in the case of a hold during the terminal count? Do you have the opportunity to reset the launch vehicle and try more than once in that 5 minutes, or is it kind of a one-and-done scenario?
Yeah, realistically, once we get to, that far down in the count, we will select a launch time. It's very unusual that you would have a situation where, a 1 or 2 minute hold would save the day, but it certainly isn't, out of the question. And we certainly use that 5-minute window to work around colas and other things like that. But it's pretty tight. You miss that 5-minute window, and then we're done for the day. But we do have the capability to turn around after a scrub. Dale and his team have all the right commodities and everything ready to go, and we should be able to give it a shot the next day.
And that was part of what we took advantage of in the downtime to really upgrade our capabilities. So essentially, we can go recycle, 24-hour recycle day after day after day after day. The people will time out before the facilities. And that's the way you want it.
But to address your question, we can't back up in the time or in the countdown.
That's right.
If that's what you're trying to get to, because for safety and reliability and hardware reasons, we just keep continuing forward until we get to this point.
We're going to try to take a question from the phone, and then we'll go over here.
Irene, your line is open.
She didn't get her second question.
Okay, thank you. It's Irene Fox with Reuters again. I'm going to just ask these two questions together and get cut off. The first, I wanted to ask Frank about FAA launch license. There's a pretty significant hike in how much liability insurance you need to carry for this flight from $6 to $90 million. Is that because of the rocket configuration, or because you have a fancy pad now? And for Joel, what manifest changes were there to OA-5 following the SpaceX September 1 accident and temporary grounding of Dragon? Thanks.
I'm not familiar with the issue you're asking about on the insurance requirements on the launch license. I think it's pretty much the same as it's been on previous CRS-1 missions. There may be some changes when we get into CRS-2, but right now the licensing is the same as it has been, and the analysis being conducted by both the FAA and the range is actually better than it's been in the past, more sophisticated. They put a lot of effort into getting ready for this particular launch and increasing our launch probability. We're very happy with the teamwork between all the parties involved here.
And on the manifest question, we originally had some ballast that we were flying on this vehicle. We've removed all that ballast, and we've replaced it with crew supplies, food, clothing, some computer resources, some upgraded laptops, and then some very small amount of EVA hardware, or extravehicular activity hardware.
All right, we'll go down here.
Hi, my name is James Robertson. I'm with the NASA Social Group. My question is about the Sapphire experiment. Are there any special considerations that the ISS crew has to make when loading the Cygnus back up for deberthing and to not, mess with that experiment? And is there any would there be any adverse effects if, say, that experiment set the whole container on fire before re-entry? Thank you.
The way the experiment is designed, and it's been tested extensively, is that it cannot activate itself prior to leaving the space station. It has several inhibits that keep it from receiving power or being able to ignite any of the material, and we're very confident that that's going to work that way. The NASA Glenn team has designed it that way. We've integrated it into the space station with the right, our space vehicle with the right safeguards. All the crew has to do is make sure that the ventilation paths remain open and they stay out of the keep-out zones when they load the cargo, and otherwise they don't need to touch it or do anything to make it ready to activate when we leave the space station. So we feel like it'll go just like it did last time.
Yeah, and when we did this on the last mission, we had no issues with maintaining the keep-out zones and the ventilation requirements.
We'll go back here.
Arsenio from Team Marinus Arduino. I'm part of the National Social Group. I got a question. Why were there not many photos available of the damage to the pad after the disaster?
There were lots of photos.
All I saw was one very distant one and one that just barely showed the crater by the pad.
Can't help you there. I found them.
I don't know where you looked, but I saw photos everywhere on the media.
Do we have any other questions in the audience? We have one down here in the front.
Gene McCullough for Talking Space. For Dale Nash, this launch is going to be, we have an election going on. This launch is going to be looked at all over the place, including over in D.C. What do you hope that folks over in D.C. that are trying to go ahead and get a budget together for all this are going to go ahead and look at it 8:03 and notice this thing arcing over? What do you hope their thoughts are going to be? Thanks.
Well, I spent a lot of time launching shuttles in Florida, Frank, and a few times, several times. And there are tremendous advantages to being within driving distance of Washington, D.C. I think we have 2 buses now coming down from D.C. with staffers who are very, very interested. And it is always a tremendous advantage to have someone come down and experience a launch versus seeing it. As all of you know, there's a huge difference. So we're very, very confident. We think it will put on a great show, and nighttime launches are always really good too. So we hope it puts on a good show for everyone. They enjoy some of the Chincoteague oysters as they're down here, and everyone enjoys it. And we get a wide viewing angle where a lot of people get to go out on Capitol Hill or elsewhere in the Northeast here and or Mid-Atlantic and have a good look at the launch.
Yeah, Kate and Sandy, you got over 100 people coming from the Hill, right? From Washington. 130, they said. So there'll be plenty of people from Washington here to watch it. And for those dozen or so people in Washington who are watching this press conference, you can go anywhere on a high hill and look to the southeast at about 8:05 and see us rise above the horizon. Maybe there's 20. I don't know.
We'll take a question here in the middle. We've got time for a few more questions.
This is Michael Marks from the Richmond Times-Dispatch. I have a question for Dale Nash. Given the state's investment, you talked about a Virginia-centric program. What are the opportunities that this offers for the state, you think, as a business investment in the facility?
Well, Wallops has always had a significant impact here, but it has been palpable even in the 4 years that I have been here, the impact that the additional work and employees from Orbital ATK, ourselves, and then our suppliers that have begun to migrate up here has had on the area. If you look at this rocket, I think we could get very busy here in the next few years. This is not me, this is the Chincoteague Chamber of Commerce states that each launch is the equivalent of a pony swim, and those of you who are familiar with Chincoteague, that's the biggest event here.
Which pony?
One thing that you asked about CubeSats, but one thing that we agreed to in our long-term agreement with Orbital ATK is we, Virginia, get the equivalent of 12U CubeSats each launch after we get, I mean, not right now, but as we get through all the approval and everything, the safety, and they will be on the second stage. So it will be a short time in space, and we are trying to get that to pocket cubes. So you can imagine 96 pocket cubes on every launch and the impact that would have on the STEM. And obviously Virginia will have a high preference for those pocket cubes, but it won't be too long before we have exhausted the people who want to come in Virginia, and I see that spreading out well across the nation, maybe internationally. So we're very excited about that, and the commitment from Orbital ATK to let us pursue that as part of the impact, not only economically that we get for Virginia, but the whole STEM arena.
If I could just clarify, what Dale is talking about is not satellites built by companies or large organizations, but satellites and experiments designed by students all the way down to elementary school. Lots of high school students are building CubeSats, college students, and so we will be exposing or enabling the exposure of space experimentation to people all the way through the school systems, spreading out radially from here at Wallops. I think it's a big deal.
Okay, I think we have time for one more question. We have one over here. We have one over here.
Jeff Faust, Space News. For Mike, just curious, will the launch of the re-engined Antares look any different from the older versions? Will it be faster, brighter plume, anything that you might notice compared to the previous ones?
Well, the thrust to weight is a little bit higher, so it may come off the pad a little faster. This thing comes off so slow, I'm not sure that a little faster is going to be noticeable, but. Beyond that, I don't think you'll tell a difference. As I mentioned in my video commentary, it'll actually, because of the higher performing engines, where you'll really notice it is at the the end of the mission. We'll have Cygnus in orbit about a minute earlier than we would have on a previous version of Antares.
Don't have to hold our breath as long.
Yeah, that's always appreciated.
Yeah.
That's all we have time for today. I'd like to thank everyone for joining us. If you're on the East Coast, there's a chance you might be able to see the launch from where you are. Check out the viewing maps online, and you can find those maps and more about the mission at nasa.gov/Orbital ATK. And also tune in tomorrow night. Launch coverage begins at 7 p.m. Thank you.
It was a pleasure.